So a class called as treeset. So treeset is a class. So what is this class? It is a set. Again, this class has all features as what are set here. So it does not allow any duplicates, no ordering, no null values kind of things all. But this tree set class, whatever the tree set class we have, so this tree set class is going to arrange the objects in a particular sorting order. So whatever the objects you add to this tree set, it is going to arrange these objects in a sorting order by default. So if you want to, while you add your elements, while you collect your objects and you want to make a group of these objects as well, if you want your object to be sorted, I don't know in what order I am going to collect my objects, but I want my object to be sorted in a particular order. So that in that case it is always better to go for what? A tree set. And it will arrange the objects in a particular sorting order. By default order is ascending order, right? And so you can change this by default nature of this tree set to whatever the sorting order you want according to your requirement. So you can change its default nature also, right? So that is one class we have, that is a tree set class, by using which we can perform the operations, right? So here let's try to see what is the tree set class and how to add the elements to this, and what it is going to do when I add the elements to a tree set here. Public class tree set. It is also one kind of set here. Demo is my class .java. Right now, whenever you want to use the classes from util package, you need to import it java data util.star. All right, now I'm going to use the class here. Just if you want to use any collection class, just need to create the object for that class. The class is this one, tree set, some ts is equals to new tree set. This is how I'm going to create the object for this class, right? Tree set dot add of. Now because this, whatever the data you add to this tree set object, so this data will be automatically sorted, and the by default sorting order would be ascending order here, right? So here now I'm going to add my data like this. Let's suppose I don't know how I'm going to add. Let's suppose I'm taking the data like this, 6. Right, and it will not allow any duplicates because it is a set. All set properties will be followed here. Right, so I'm changing the data for some 3, 1, 5, something I'm adding here, and the last one is 2. Now just I would like to print the data from this, like a system data out dot println. Now just I would like to see what data is there. It is going to just print you the data, right? So just I have created an object for a tree set class and I'm adding the data randomly. So this is not a primitive actually. Internally it is converted to a equivalent object, right? So we have a auto boxing and auto unboxing kind of concept which is introduced in 5. So it is going to internally convert it to data, right? cd, right? Reset demo.java. It's fine now. There is a semicolon missing here. It's fine now. Reset demo. Now you can see here. Now if you see the data which I have added to my tree set and the data which is added into the tree set. So while adding the objects to a tree set, what is this add method is doing? It is trying to arrange them in a particular order. See here. Now you can see the by default order, as I told you, it's a ascending order of numbers, you can see there. Right? So if you add any data here, they are going to arrange, this tree set is going to arrange the data in a particular order. But now as we discussed previously, right? So a collection is an object which can take heterogeneous as well as what? Homogeneous data. Right? Previously we have seen, we have tried to collect it, we try to add student objects, data object, this object, strings, integers, the counts and all in the previous. Now is it possible for me to add whatever the data, like heterogeneous data, to this tree set? Is this tree set allows me to add heterogeneous data to it? Right? That means now heterogeneous, let's suppose I would like to take one string data inside this, where I'm going to add ABC. Now what is its nature? This object's nature is, when you try to add some object to this object, it is going to sort them in a particular order. Now is it going to do this sorting for me or not? I need to see this, right? Now see here, it's compiled fine, but it is saying boss, I cannot compare them. I cannot compare them. String cannot be compared to what? Integer. So it is a very basic thing here. So it's a very basic simple rule we have here. Comparing means what? When whatever the things in regular also, in real life also, what is the meaning of comparing here? Comparing, ordering, first thing ordering, sorting. Sorting means what? Internally we need to do comparison. Then after comparing the things, then we arrange them in a particular order. Sorting means what? We need to compare internally. After comparing, then only we arrange them in a particular order. What does actually the meaning of comparing? When you want to compare two different things here, what do you do generally? Can I compare a child with some other object? Whenever you try to compare the things, generally we always go with the same type of data. So here is also the same problem. It is trying to compare ABC with 4. But how to compare ABC with 4? Both are two different types of data. In our regular life also, whenever you want to compare, you always compare with what? Pen with other pen, but pen with, not with pencil or some other objects. So comparing means homogeneous. Tree set, when you try to add the data to a tree set, yes, it is going to arrange the data in a sorting order, that is fine. But what does it mean sorting the things is? The data should be homogeneous. It will not allow you to compare heterogeneous objects. It will not allow you to compare what? Heterogeneous objects. So whenever you try to add the data to a tree set, this data should be first homogeneous. Not only homogeneous, the data also must be comparable. Otherwise, it is not possible to compare. Tree set cannot compare the things. It's fine because adding these strings and integers is fine. But if I add student objects, all student objects, let's suppose a student object is there with some data here, right? So let's suppose a student object is, student means what? So you can take some set of properties inside that object. Now if I have a student object like this, if I am having multiple student objects, and when I add all these student objects to what? Right, let's suppose there are 4 student objects. I want to arrange them in a particular sorting order. Let's suppose these student will have a roll number, name and age. Each student will have a roll number and name and age. Now I would like to add these student objects to a tree set, and at the same time I want to arrange them in a particular order. What is the meaning of arranging the student objects in a particular order? Because this is not a simple data like this. The student object is a combination of what? Multiple fields. Now if I want to add these student objects to what? To a tree set, and as we are discussing, a tree set is going to arrange your objects in a particular sorting order. Now how these student objects will be ordered? What would be the order of student object? Whether the student objects will be sorted based on their roll numbers, or they will be sorted based on their names, or they will be sorted based on their ages. The student is not a simple data like this to arrange. It is bit complex data. right? Though all students have, there is a very key point here. So though you have all data of same type like this or this, first thing is you need to have all the data of same type, then only it can be compared. If you have different type of data, it cannot be compared. There is no meaning of comparing the data of different types. The first thing is the data must be same. Though the data is also of type same, you cannot compare in all cases. Now it is, what is the meaning of comparing the students? All students are of type what? Student type, each and every student object is of student type only. Now how would I compare them? Now if you take 4 student objects, if you take a class, if you imagine a class with 4 student objects, what does it mean of comparing the 4 student objects? Whether you want to compare these students by using their roll numbers, or names, or age, or marks, how you would like to compare them? Right? So though all are of types of what? Homogeneous. The first rule is fine. The data is of type homogeneous. Means what? All are of type students only. All are of type students only. But though the data is also of type same, it's not possible to compare them. Right? So then what is the meaning of comparing such kind of objects? How can I compare such kind of objects? Right? So the objects which implements an interface called as comparable. So whatever we are talking about the students, now let's suppose if I add a student here, I think I have a student object, new student in my, already there is a student class is there, I think. Now new student, I am creating new student object here. Both are of same type or not? Both objects are of same type. Just I am taking 2 objects only. Now they need to be compared. How it is going to compare? Based on what parameter it is going to compare? Right? No, it cannot compare here. Saying what? Same. A student cannot be compared with other student. Why? Why it is not possible to compare a student with other student? A student is not a simple data. It is a complex data, which is a combination of multiple fields. Then how first student is compared with second student? What would be, whether these 2 students should be compared with roll numbers or names? So if you want to make a students as comparables, right? How can I make the student objects as comparable? Right? So the class objects which you want to compare, that class should implement an interface called as comparable. The objects which you want to compare, those objects must be implements an interface called as what? Comparable. If the class implements this comparable interface, then only those objects are said as what? Comparable objects. Then only they can be compared, otherwise they cannot be compared. Right? So I am going to write my student class here. I am going to modify my student class. There is a problem here. Whenever you want to compare the students, that is the reason why it is not allowing me to compare, because my student objects are not comparable. Though both are what? Both are same type of objects, but they are not comparable. So how can the class becomes a comparable? Or how can objects becomes a comparable? By implementing a method interface called as what? Comparable interface. Now this is a fundamental rule we have here. Whenever you try to override a interface, you need to override the methods from that interface, and there is one method is called as what? Compare to. Now you need to override this method, which takes now object. Oh, just I am writing this according to some principles. We have rules. We have, whenever a class implements an interface, that class must override all the methods of that interface. Now just I am doing this. So there is a method called as compare to method in that class. In that interface I am overriding it, and which expects what? Integer value. Right? Just I am writing return 1. Now what it is going to do? Just, so I am saying first thing is, if you want your student objects to be compared, this class must implement an interface called as comparable. Then only this class is said as what? The objects can be compared. Now when a class implements an interface, this class need to override a method called as what? Override the methods from that interface, and this is the method which is there in that interface, and overriding it, which returns you what? Integer. Now let's see here. Let me compile my program, what it is going to do here. It's fine, compiled. Now see that you don't have any error. Now you can see the object references here. You can see your object references, but previously it is like this. It is not giving any error. Now it is executed and student objects are added to what? Tree set. Right? I did not written any logic how to add them, how to compare them, whether you want to compare them by using what rule numbers or something here. I did not use anything here. You can write your own logic inside this comparative method. If you want to compare them by using rule numbers or something, you can do that. Right? So that is what you have here. Just go through this method once. So whatever the objects you want to add to a tree set, they must be homogeneous. That is the first rule you have, because tree set is going to compare them. So comparison always happens in between the same type of objects, right? And if it is by default, if it is these numbers and strings, it is fine. But whenever you have your object to be sorted, then that class must implement an interface called as comparable by overriding a method called as compare to. This is what you can do here. Now my objects are able to add it to tree set, because how many students you create, each student will be, right? Each student will have what? Each student is a comparable object. Now when you add a second object here, the second object is compared with first object, because this class is implementing what? Comparable interface. Now student class is set as what? Comparables. And this behavior comes to this class by implementing an interface called as comparable interface. Right? So this is what we have. This is what something special about this class here, tree set class. Now because is all basic fundamental mathematical rules we have here. Comparing, sorting means comparing means what? Homogeneous data. Right? And this is how you compare the things here. So this is what you have tree set here. It is going to compare, right? So this is how we work with what? Sets and lists. So we are talking, we are talking, keep on talking like what is a collection object? That's your logic. See, this basic these primitive data types by defaultly having a comparison logic. But if you want to compare your students, let's suppose a student object is having a rule number, name and age. If you want to compare the students by using rule numbers, you need to write the logic. Where you need to write the logic here? You need to write the logic inside this method. Inside this method, you need to write the logic of comparison. If you want to compare the student objects by using their rule numbers, write the logic inside this, and it is going to compare them by using rule numbers. If you want to compare them by using names, yes, write the logic in the here only. If you want to compare them by using ages, write the logic by using this one. So here I did not written any logic. Now the logic should be kept inside this method. How you want to compare your objects, because these objects are created by you, and as a programmer you should know how to compare them. And if you want to write it, first your class need to be, that is true, right? Because this class is not there. How Java knows student to compare a student? Because this is created by me, and definitely as a programmer creator of this, I need to know how to compare my objects with some other objects. And if you want to do that, you need to override, you need to implement an interface called as what? This one, and you need to override a method, and you need to write your logic inside this, how to compare the student objects. This logic is entirely depends on you. Very simple to write anyway, right? So that depends on your requirement, but writing the logic is simple. Just go through this, just write. If you don't understand, I will explain this later, right? So till now we have seen adding the objects and retrieving the objects, and let's suppose if we take our first program, array list program here. So in this array list, right here, now I have added the objects. Now it will not work here because tree set, and you are trying to add different objects to this. It will not work, right? So this is a previous example. It is also not works there. I have student object, I have account object, and number of different objects. It will not work, right? So account cannot be casted to what? Student or something here. So S means account object, S means student object, A means account object. I am adding to all to what? A tree set. Now it is not possible to compare all these things, right? Now we are talking about this adding the elements to array list to a collection object. It can be any collection object, depends on its properties. You need to choose one. Now I'm taking the array list. Yes, what its behavior? Array list is the object. What it is going to do here? So it is list. When you have a list, it allows you duplicates and it maintains the ordering. Just I change my class. Now you can see the program output will be changed. It is not a tree set. Now it is going to take whatever you add. Everything is accepted by this kind of collection, and it maintains what? The ordering of this, insertion order of this. So first object will be first, student next, account next, then one is next, like this in the same order. String student account and one, string student account and one, string student account and one, like this you have. Right? So now we are talking about adding, and this is how we can test whether the data is there or not. Right? It's a content searching, and if you want to retrieve a particular object, you can use system data out dot println. So when you talk about list type of collections, so you can use indexes to get the data. Get of let's suppose I'm going to get the data from 5th index. It is going to return you the data from the 5th index, right? If you want to update the data inside a particular index, there is a method called a set method, which is going to update it. Lots of methods are there, very simple to work with this. So set then 5th index, I'm going to replace it with some data here. After replacing this data, I'm going to again, I would like to get the data. So get of 5. So what is this? So I'm trying to get the data before updating, and I'm trying to get the data after updating. It's fine. So this get method returns you one object at a time, right? Now let me compile this and let us see here. It's fine. Now I can see before false. Why I got false here? I'm checking whether hello is there or not in my collection. No hello. Then I'm printing get of 5. What is the meaning of get of 5? I'm trying to get the object which is inside 5th index. I think it is student object. This one is returned for me. 0, 1, 2, 3, 4, 5. This is returned for me, student object. And I am setting it. Not required actually printing it, but it prints also, it gives. I am setting means what? In the 5th index I am replacing a student with what? S, right? Now what it is going to do here? False, there is no hello. Right, in the 5th index I have a student, then I just replaced it with what? A string called as SSS. After replacing, I am trying to get it. It's fine here, but if I want to retrieve entire collection at a time, entire data, I want to retrieve the data from beginning to end. How can I retrieve the data from beginning to end? Right? There, as a programmer, you can write, if you want to retrieve the data there, generally you can go with what? Simple for loop, where it works for you, right? Int, because always index starts with 0, right? And index less than or equals to, less than not equals to here. Dot size, there is a method which returns you the size, right? And increment the index. This is what you can do. Index plus plus. Then you can use system data out dot println of what? Collection object dot get me the data from each and every index. This is what you can do. This is a simple for loop. You can write like this so that it is going to iterate through your complete collection, and it is going to retrieve the data from beginning to end. Right? Only this you have? Yes, it's fine. See here, student object, account object again. Like this it is retrieving me all data. right? So what I'm doing here, just I'm checking how much size my collection is. I'm using the index starts with 0 and I'm just using a simple for loop here. But instead of going this collection framework provides you with some kind of different mechanism to retrieve the data from this. So this we call as, technically we call them as cursors, right? So I'm writing my own for loop and starts the index and all. If something goes wrong in the for loop, there is always a possibility of getting some kind of exceptions and all. Instead of doing this collection framework provides us some kind of implicit mechanism, right, by using which you can do this kind of iterating through your collection. The first one is called as iterator. So what is this iterator, or we call them as what? Cursors. Cursor, what is the meaning of cursor? We talk later here. It maintains some kind of cursors. There are 3 different cursors are given for us, by using which you can do these kind of operations. The first cursor is iterator. I can say what? Iterator is the first cursor we have, by using which you can iterate through a collection. So what is the meaning of this? Instead of writing your own logic for index checking and checking the size and incrementing the index and getting the data and all, so it's simply you can do what? Al dot, there is a method given iterator. So what is the meaning of al dot iterator? So it creates you one type of cursor. Now this is my collection object. Let's suppose this is my collection object where I have 16 objects stored in my collection. So this is a big object where it has 16 indexes, and in each and every index there is one object is stored, one string object, one student object, one account object, one integer object, like this. Now when I call this method, what is this? When I call al.iterator method, what it is going to do here, right? So what it is going to do here, this is my collection object. When you call that method, by default there will be one cursor will be created, one pointer kind of thing will be created, and this cursor will be placed on top of what? First record. It will be placed on top of first object. Now you can simply move this cursor to a first position. You can simply move to this cursor to a first position, and after moving your cursor to this first position, you can get the object from this position. This is called as what? Cursors. So instead of writing for loop and all to fetch the data, so there is by default mechanism is given. So positioning your cursor to a particular index without using any indexes. There is a beauty of these iterators. Without using any index, right? Without having any index, so it is going to do this operation for you. Same like for loop, whatever I have written previously, it works as the same. But when you create this object, when you call this method, what is that method here? This is the method collection.iterator. What is going to do here? It is going to place the cursor on top of your collection, first object, on top of first record. Then I need to check whether it is there or not. If it is there, retrieve the object. If it is not there, then simply stop it. Now how I'm going to do this? Getting me what I'm trying to explain here? Instead of writing your own logic, just you can take the help of some kind of cursors, and out of these what is the iterator is one type of cursor. So al is my collection object. Al is my collection object. On this, when you call this iterator method, it gives you this cursor, and this cursor is called as, what? What is this cursor is said as? The cursor name is iterator. We call this cursor as iterator. I-E something. We call this cursor as what? Iterator. Right? Now what happened here? When you write this statement, so there is one pointer is created for you, and this pointer is pointing to a location on top of the first object. Now from that, if you want to retrieve the object, first you need to move the cursor, right? So by checking whether the object is there or in the next position or not. So what is it? We have a method called as hasNext. HasNext is a method. By using this, you can check whether there is a data is there in the first position or not, in the next position or not. If it is there, it returns you true. When it is returns you true, your control enters into while loop. Then from that position, get the data. How to get the data? Next method returns you the data from that position. IE dot next places the cursor and next retrieves the data. It is almost similar to this logic whatever I am written here, but instead of using manual code, I am taking the help of a predefined code here. Predefined some classes and interfaces. Very simple, right? So what is it going to do here? So no need of calculating index and all. It starts fetching the data from before first object. So it is positions your cursor to the top of first object. Then it moves the cursor to the data. If it is available, no, then it returns you what? False. Then it gets you the object from that position. You see the same output. There is no change in the output, but the way I am fetching the data from my collection is different. Instead of writing my own manual logic of index starts with 0, then check the index, then increment the index, then get the data. No, these are all not there. Internally it is going to use the help of what? Iterator. So what is iterator here? What is iterator? Iterator is an interface. What is iterator? So this statement, when you see this statement, where we see this? This is what? Assignment operator I am using. Assignment operator means what? Some data, this side will have some data and this side will have some data type. So what is iterator here? Iterator is one kind of type. It is an interface, and this side you will have a child class object for this interface, and I don't know what is the child class object. Superclass reference subclass object, because this iterator is an interface, and this one gives you one child class object, and it helps you to iterate through what? That collection. Now always it starts fetching the data from, you cannot move from a particular location, you cannot fetch the data in reverse direction. Always what is this, how it is going to fetch the data? It always starts fetching. So as we told you, this statement is executed, your cursor will be positioned on top of first object and it moves in this forward direction only. Always the cursor moves into the forward direction only. So first object will be fetch has next, checks whether the object is there or not. If it is there, position the cursor to the first object, then fetch it, then again position it, fetch it, position it, fetches. It moves always in forward direction only. You cannot change the cursor position to a particular object. Now I would like to start fetching from second object. No, it is not possible. You cannot place the cursor. Or if you want to fetch the data from reverse direction, it is not possible. This is iterator, always fetches from top to bottom, right, in the same direction. It is forward direction, right? Getting me? It always moves in only one direction. You cannot position your cursor to a particular object, and it starts from what? Iterating from first object and it stops at the end. Always, if you don't write any logic to make this while loop break or something, it starts fetches from what? It starts fetches from first object and it stops it in the end, last. Right? So this is an interface. And this is how, if you want to fetch the data from any collection, that means what? If you want to fetch the data from a list collection, or if you want to fetch the data, all data I'm talking about, not single, right? So if you want to fetch the data from a collection called a set, absolutely you can fetch the data by using this kind of interface. It has two simple methods, has next, one more is there. While iterating through the collection also, you can remove the data from that while you iterate through your collection, you can remove the data also by calling the remove method. Try to position the cursor to that particular object by using has next, then remove it by calling remove method. Or if you want to make your iteration, right, because it has some limitations. What limitations you have with this iterator? Only moves in forward direction, cannot place the cursor to a particular object to retrieve it. If you want to do all these things, instead of going for iterator, yes, one more different type of cursor is given. that is called as list iterator. What we call this? List iterator. And it works with only list type of collection. It will not work with any other type of objects. It will works with only list. It is called as what? List iterator. What is its purpose? So to get this cursor, we use a method called as list iterator. So what is this going to do here? So it has more benefits over iterator. So it can move in forward as well as what? Backward direction. Or it can position a cursor to a particular object. Then from that it can fetch the data. Right? So now this program I changed it to some other. Now let's see what it is going to do for me. It is almost same output you will get because I am not specifying any cursor position to a particular object. All data from starting to ending. Now I would like to place my cursor to a position, let's suppose 6th index. I am passing the index. Now let's see what it is going to do. Has next and next. It starts fetches from 6th index and it gives me the data. Now see here what I am going to get here. You can see here it did not retrieve all the data here. You can see only few objects are retrieved for you. Right? This is complete my collection, but from this complete collection it started fetching from what? This one. 6th index. Right? In the same way you can move in backward direction also. How to move in the backward direction? We can call a method called as previous and ie.previous. So what I am trying to do, instead of moving forward direction, I am moving in backward direction from 6th position. So you will see the data from 6th position to 1st position. So you can see the data in backward direction. Right? Let me compile this. See here. So first you got student before account object, then this one, like this. This is after data. You can see this, two different data you have. This is after the account object, this is before the account object. Right, so this is bit advantageous, this list iterator. So you cannot do this kind of operation by writing for loops and all. You can do, but it is bit complex. Now if I want to write such kind of for loop, whether to move backward or forward, you can write absolutely, but it is bit complex. Instead of doing that, you can go for this. And the most important thing, this cursor works with only list. It will not work with sets. Right? Fine. And this is the architecture here. List iterator, and you have iterator, and we have list iterator. And both are interfaces. Remember, this is very important. Whenever you come across a cursor, always the cursors will be interfaces only. And the relation is there between these two. List iterator is a child interface for iterator. So it has some limitations. It is more than iterator. So it can move, there is a spelling mistake, it can move in both directions. This one can move in both directions, and it can be used with any kind of collections, but it can move in only one direction, forward. Right? This can be used with any type of collection, either list or set, but this can be used with only list type of collections. Right? And this is how we can use them. This is how we can use them. Just go through them. Again, you can find them in the API. Just check the API and go through them. Right? So this is how, if you want to get all your data from your collection, you can get it by using these methods. Right? And here, because a collection allows you to add different types of data. This is string data, this is integer data, this is account object, this is student object. What is this next method is going to do, or what is this previous method is going to do here? Right? It will not return always a string. Because I have heterogeneous data, then how it is going to return the string, right? It will not return the exact strings or integers or students or accounts. No. It is not going to give your exact object. It will give you the data in the form of what? This method will be give you the data in the form of object, superclass reference. Then from that you need to downcast it to your subclass object. Right? This entirely this will be depends on what? Superclass reference and subclass object. Because see here, what I am trying to do, I am trying to fetch the data. I am trying to fetch the data. What data I have in this position? String, let's suppose. In the next position I have a student. In the next position I have a account. In the next position I have a integer. How it is going to give these different objects, the same method? A method can return you what? If a method returns you some data, it always returns you what? Only one data. It cannot return you different data. A single method. Is it possible a single method can return you multiple values? No. The same method, how it gives a string, or how it gives a student, how it gives a integer, how it gives some kind of account. No, it's not possible. That is the reason why. So this method returns you what? The data in the form of object. Then once your data is there in the form of object, from that object you can convert it to what? Your actual object. That you can do. Downcasting. We call it as downcasting. Right? So this is something related to what? Iterating through your data over a collection by using iterator or list iterator. Right? So you can use any one here. Now let's suppose now I'm going to do this one. Now I'm just trying to change my data. So what I'm trying to do here, it is a array list. It is an array list. And list means what? What it is going to do here? There is no sixth index. Absolutely, it will not work. Throws you an error, index out of bounds kind of things. Yes. Now here, if I don't specify any index here, it starts switches from first. Now because it is a list, how it is going to store the data? In the same order how we store it. This is a list and it is stored the data inside this. And now let's see how it is going to give me. 5, 4, 2, 1, 3. List, right? Order, maintains the order. It is not sorted, it is array list. It is not a tree set. If it is tree set, then it is going to arrange your data in sorting order. It is list. List always stores the data in the same order. Now on this list, if I want to sort this data, I want to sort this list now. I would like to sort this list. Is it possible for me to sort this list? Right? Now you need to do what? Get first object and get a first object, then get the second object, compare it with what? First object, then arrange them. Right? So in order to do that, actually, there is one class is given that is called as utility class. When utility class is given, with the help of that class you can do this. That utility class name is collections. It is not a interface. Collection is an interface. That is a class called as collections. Now in this, with the help of this class, you can just call a method by passing your collection object. Now it is going to sort your objects. No need of writing your logic. Yes, if you want to write your logic, absolutely fine, you can write it. Instead of writing your own logic, so you can take the help of this class with all static methods. Class with all static methods can do for you. Now before this sorting, and this is after sorting. Now let's see what it is going to do for me. See there, this is before sorting and this is after sorting. So it is also possible whenever you have the data in array list, it is possible to sort them. No problem. But as usual, when you want to sort, you need to have what? Homogeneous data. Yes, same thing. If you want to sort, you need to have the data is added here, but if you want to sort them, you need to have what? Homogeneous data. It is unable to sort my data because it is not homogeneous. Right? So like this you have collections. What is this collections? It is not interface, it is a class. Collections dot static method. Like this you have few methods in this collections class. Right? You can swap the elements in the collection, you can do whatever you want to do, you can do with the help of this class. So like this you have collections, collection, group of objects, right? And you need to pick the complex part of this collections framework is whenever you implement your whenever you have huge data, choosing the particular collection for to store your data is a bit complex. Remaining all are simple. Like whether I need to take array list or whether I should go for linked list, whether I should go for hash set or tree set or which class I need to use so that I can manage my data very properly. That entirely your requirement dependent to choose one of these classes. Right? So if you want to go for sorting, go for tree set. If you want to go for no duplicates, then it is better to go for hash set. If you want to have duplicates, then go for array list. So like this, different collections are used for different purposes. The important thing is, as a programmer, I don't much need to take care here. Just you need to choose the class name, which class you want to use, and add the data to it. That's it. Very simple, switching from one collection to other collection. That is the beauty of this framework. Now I can change this array list to linked list. I can change this array list to hash set. I can change this array list to tree set. I can change it to what? Vector without changing my code. Without at all changing my code, I can make these changes. Just change the collection name. Your internal data structure will be changes. That is the beauty of this. I can change it to hash set. Absolutely it works. Hash set, yes it works. I can change it to vector, it works. Anything I can do here. Very simple. Now hash set, the internal data structure, the data storage will be changes here. No suitable method found for hash set. Right? It cannot compare the things. That is a problem. This sort method is not there. If you comment this sort method, you will see the same. It works. Because already if you want to sort the objects by using set, you can go for tree set. No need of hash set. Right? If you want to sort the things, why should I add them to hash set? Then again I need to sort it. Directly you can add them to tree set. It is going to sort the objects for you. Right? So like this you can just simply change the class name, it works. If you want to go for vector, you can go for vector by simply changing the class name. Now you can call sort method on the vector. It's fine. Right, so this is what we have here, group of objects. Apart from this group of objects here, grouping the things, the one most very important combination we always come across in our regular life, we always come across, which we have not discussed, a group of objects. That is technically is called as map in Java. Is one more root interface, map. What is the meaning of map here? Very regularly we come across, everywhere we come across mapping the things. Everywhere we come across mapping the things. What does it mean? Right? Let's suppose whenever you have a student object, right? Or whenever you have a person object, this person is mapped by a name. A name will be given to this person to easy identification. Whenever you have a details of a particular person, card number, Aadhaar card number, a number will be associated with what? A complete person detail. A house object will be associated with what? A address. To easily identification. Mapping the things. Without this, that very commonly used. Let's suppose if you are trying to maintain the data of what? Telephone numbers. How do you maintain the data of telephone numbers? A number will be associated with what? A name. Or a name will be associated with what? A number. A student. How we maintain the student complex student data? By assigning what? Rule numbers to each and every student. A rule number will be assigned to a student for easy usage of data. That is called as what? Mapping. Yes or no? Everywhere you come across here. As a human being object, I'm having a name. Nothing but a name is used to easily identify that particular object. Everywhere. Employees given IDs, bank accounts associated with particular data, huge data. Whenever you have a huge data, to easily refer the data, instead of taking all data, a simple unique number is associated with bank account numbers, employee IDs, unique ID. Everywhere you come across this kind of mapping. So that is nothing but what? A map. Now you might have understand what is a map. Mapping the complex object. Whenever you have a complex data, map this to what? By using a simple data, so that you can use this number to get what? This complex object. Everywhere, general case serial numbers is the most common example. Serial numbers associated with some products and all. Unique numbers of banks, employees, humans, Aadhaar card numbers, election voter card numbers, what not. Alright. So here, so this is what map. Map is nothing but again this is a different type of data you have here, where it is a combination of what? I can say two different data fields. It is a combination of what? Two different data things. Right? So what you can see here, a map is nothing but mapping the things. You very regularly we use it. Right? So map is nothing but what? Here it is a map is nothing but a combination of what? Key and value pairs. A key and value pairs is called as what? A map, where a key is associated with a particular value. And these keys can be your choice and values can be your choice. That's completely depends on your requirement. Most of the cases we use simple integers or strings as our keys. Yes or no? Right? So easy whenever you have a complex data to refer, instead of referring that whole data, we simply associate with its simple a unique value, a key we say. Right? So like this, each and every key will be associated with what? So this combination of data. So this is one that value I will have here. One value I will have here in this, and one value I will have here. And one acts like a key, one acts like a value for this. So this association is called as, generally we come across one-to-one kind of association in database and all when you go with. This is called as, now this complete entire structure is called as what? This entire structure is called as a map. And this part of the map is called as, this piece of the map is called as, which acts like a keys, which acts like a what? Key. And this objects is called as values. If you take any database like bank account database or student database, employee database, this will be there. Right? So there is key and value. Right? So this is one pair here. You will have one pair like this. What is a one pair here? When you do this, this is becomes one pair. One key and one value pair. This is one pair. One key and one value pair. This is one pair. One key and one value pair. Yes, absolutely. Everywhere you come across this. Without this, most of the logics cannot be solved. Right here, generally, if you take the employee as you have given example, employee, what I will see inside this, here you will have employee numbers. One employee number one associated with one employee object with so and so details. Huge data will be there inside this employee data, entire employee data, like his name, number, address, salary, experience, whatnot. Here too, this is a second employee associated. This data is, this simple number is associated with what, 2. Now when I say 2, it is referring to what? One employee object. Now having this key and value pairs is called as what? A map. Mapping the things. The name itself says map. Key and value pairs. Right? So whenever you want to arrange your data, whenever you want to collect the objects in the form of key and value pairs, that we call as a map. This is bit complex than what? The previous one. Where we have single objects there. In the collection we have what? Collected a single objects. But here pair. A pair of objects I am trying to collect here. And one pair is called as, and pair and pairs. One pair, in a pair we'll have what? We'll come across two things. What is that? A pair means what here? A map means a key to a value. A key associated with a value is called as what? A map. And one pair. One key and one value is one value is called as one pair. Yes or no? So this kind of collection, this kind of storing the data is also possible in the form of what? Key and value pairs. If you take, it's not different here. If you take the actual data which is stored in the memory and the address of that data, hash code. The actual data which is stored in the memory and the address which is refers to that data, hash code, and this key and value pair again. Right? So like this we have here. And this kind of collecting the data is called as map, key and value pairs. It is not different here. So a map is nothing but a key and value pair. A map is nothing but a key and value pair. Now if we talk individually, so this map, if you see this map more clearly, if you observe this map more clearly, it has 3 different views. You can see this map as a 3 different views. What are the 3 different views mean? Right? If I see only this part, if I see only this piece, what is this piece looks like? Only this piece of data. What is this piece of data looks like? Keys, I am talking about only keys. What you will see a key means. Whenever you talk about the keys, always general, most possible case, not most, like most of the times, you will find what? Keys with always unique data. It can be integer, it can be string, that's your choice. But most of the times you will take what? Unique data. So that it means what? So what is the meaning of where we come across unique data? Where we have come across unique data? Previously, we have already come across unique data. Set of keys. Set representation. Sets means what? A set collection. It is a set of keys. 3 collection views actually I can say here. Set of key means what? Previously we have seen set, hash set or tree set. What they are going to do here? They will not allow you to have duplicate data. As we are talking about set of unique values as part of what? Keys, and these unique values can be represented as what? Set. So this is the first view, first collection view. What is the first collection we have? Set of keys, because we never see what? Duplicate values. Set of keys, and this piece can be called as, so in this side, whatever the values we are talking about, this side you can have duplicates or it cannot be duplicates. You can have duplicates data or you cannot have what? Duplicate data. Let's suppose employee IDs with employee objects. If I take employee IDs with employee objects, this side you will find unique, as well as this side also you will find what? Unique. But if I take a phone number with a name, There you can, there is a possibility of finding what? Duplicate data also this side, names. So the second view, this is the set of keys. This is what the second view you can represent of, because this values can be duplicate, or these values may have duplicates or may not have duplicates. The second view you can say as collection of values. A collection may be duplicate or it may not be duplicate. Collection of values. The second view you have set of keys, collection of values. Then what is the third view we have? The most important. Right? The combination of both. The combination of a key with value is called as what? This is important for us. Set of keys, only keys, set of keys, collection of values. This is one more view. And the combination of both is called as what? A map. This is the third view. And this view you can represent as, right? Because each set is unique. Whenever you see this set is unique one, this set is unique one, this set is unique one. So that is means what? Set of key and value pairs. Key and value pairs. These are the three different views. So whenever you talk about map, technically speaking, in simple, you are not learning any new thing here. You already come across sets. So this keys represents set properties. This values represents collection properties, and the combination of both represents a set of key and value properties. Set means what? Unique. So this first pair is unique, second pair is unique, third pair is unique. Set of key and value pairs. And the set of key and value pairs is nothing but a map. So we are not going to learn any new thing, technically speaking here, because we are already we have seen the collections here. So these three are different collection views, three different collection views here. A map is nothing but a three different views, collection views. One is set of keys, collection of values, and set and value pair. Now if you talk about the specific properties of this key and value pairs, now if I ask you, at most a key can map to how many values at a time? In general I am asking. A key is there and a key can point to how many values at a time? Only one. Is one-to-one relation. From keys to values, a key can have only one value. Employee, one roll number, one employee ID can be associated with one employee object. It is not possible to have multiple employee objects can be referred by using one single key. Now if I see from reverse direction, one value can have how many keys? So one key will have only one value. It's fine, but whenever you see independently, uniquely, it is, you can say what? One value can have what? Only one key. But it's not correct. But one value can have multiple keys. What does it mean here? Because here duplication is possible. Let's suppose I have student names and numbers. I am taking names and numbers. Names will be like this. Numbers will be like this. 1, 2, 3, 4. Rule numbers. Names ABC, XYZ, ABC. One key always will be associated with one value, but ABC, how many ABCs are there? For ABC, if you see this ABC as a single value, how many keys are associated with this ABC? Many. Right? A key and value pair means a key at most can have what? Only one value, and a value can have multiple keys. In general I am talking about. If you take this kind of example, if you take employee kind of example, that is a different story. One key always will point to what? One employee only, where you will have one-to-one in both directions. But in general case, if you take this kind of relation, roll numbers and names, yes, you can have different duplicate names can be associated with what? Multiple different keys. And the most important point here is, when you are trying to use key and value pairs, both key and value pairs must be objects. Both must be objects only. Key must be an object and value must also be object. Both must be object. So in most cases we go for what? Integers and all as keys. integers or strings. Of course you can take any other. Let's suppose if I take right, if I take, let's suppose if I take a railway reservation system, now I would like to have a key with value. What is that key with value? A ticket. A ticket is the object. I can take a ticket is the object. Ticket with multiple data, and it is associated with what? Some group of passengers. Both can be objects actually, no problem. But most of the cases we come across what? Simple integer data or strings kind of things. That's your requirement dependent. But both must be of type what? Objects. So this key and value pairs we call as what? Map. Very simple. The key and value pair is called as map. Now we'll see what is this map can do for you, and so is the most important, because almost all advanced Java concepts will internally use these maps. All advanced Java technologies internally uses these maps here, right? So we try to see what is this map and all, how to work with these maps. So just go through the API once again. So this is not collection. Map is not a collection, and collection is not a map. Two different interfaces representing two different things here, right? What is that? Java.util package. We need to search it from util, and one is map. See, it is different. It is its own. It takes an object that maps keys to values. A map cannot contain duplicate keys. Each key can map to at most one value. Right? So it has three different views here. Contains a map contains a set of keys, collection of values, and pair. Set and value pair. This is called as a map. Simple, right? So this is 1.2 introduction. So what you have, how to add the elements to a map as a key and value pairs. There is a method given put. Add method used in collection, and put method is used in a map. Put a key and value pair inside a map. Remove a key. Remove takes a key and removes a key and value pair. Size gives you how much size. Values, what is the values? Gives you only values. If you call the map.values, map object.values, what it gives? Only values. Right? You can see here, there are methods here. Clears entire object, checks whether the key is there or not, checks whether the value is there or not. Entry set, what is the meaning of entry set? One key and value pair added to a collection is called as entry set. One key and value pair. If you want to get one key and value pair, you can get it like entry set. Right? Equals is comparison. Get method takes the key and returns you what? The value. Is empty. Checks. Key set. Key set returns you set of keys. Entry set returns you. What is this method? Entry set returns you the pair. This entry set returns you what? The pair of the data. Key set returns you only keys. Values method returns you only values. This is how we can get the data. If you want to get key and value pairs, you need to use entry set method. If you want to get only set keys, you can go for set method. If you want to get only values, you can go for what? Values method. Very simple, just you need to call the methods. And if you want to add key and value pairs, we have a method called as put method. So as we have discussed in the collections, how we have the implementations for the collection classes. Now in the same map also we have some implementation classes. So we don't bother about writing our own logic for adding and all. There are some implementation classes are already given for us. So by using those implementation classes, you can make it. So this is same as the root interface is what? The map is the root interface in this hierarchy. Map, right, is the root interface. Right, here we have implementation classes, and all implementation classes will have, because that is the interface, all implementation classes will have the methods implemented from this hash map, weak hash map, right? Like this you have different classes. Tree map, almost whatever the classes you find in the sets, the same classes you will find. Getting me? Whatever the classes you find in a set, hash set, tree set, in the same way you will find some classes in this same classes. Linked hash map with some slight differences. Each class has its own specific, right? So these are all classes which are implemented classes for hash map. So this is interface, implementation class of the same interface, implementation class, and one more implementation class of the same interface, right? So this is how we have the architecture of these classes. Still you have some other classes. This is a big architecture you have for this key and value pairs. These are some classes, few classes in this, and this is map interface. Actually map is, you have some other child interfaces for this, right? So I have one more interface here, have one more interface, and one more interface. Same as sets, almost it is looks like a set. Sorted map, which maintains the objects in a sorting order, right? And you have a one more interface here, navigable map. This is what you have the architecture of classes, right? So this is a child for this one, this is a child for this one, and tree map is from this one. So in between you have some abstract map and all. So here you will see abstract map, abstract class, right? So these are all classes from this one. So this is which is implements, extends like this. We have a simple architecture of classes here. Still you have one or two classes in this architecture, but all works for what? All classes here, whatever the bottom layer classes, each and every class is used to store the values in the form of what? Each and every class here, these are classes, are used to store the values in the form of key and value pairs. Apart from this, there are some old classes in this. So those old classes are like this. The first old class, legacy classes. This is what I have given in the first class. Yeah, there is a legacy class called as dictionary, right? So this is one more. You have the most important class, hash table. Key and value pairs will be stored inside a tables. And you have one more important class, properties. This is also most used class. So this is old hierarchy. Before these classes are there since Java, initial release of Java, but this API is introduced in 1.6 and it comes from this map. Old classes. There's a big hierarchy you have, but all classes works for the same purpose, storing the key and value pairs. Right? So hash map, tree map. So what is tree map is going to do? Tree means what? Arranging, sorting. Sorts your keys. Keys are going to be sorted when you use tree map. Right? Now how to use these classes now? How can I use these classes? Right? You can use these classes. Now let us try to create one class here. Public class. What is it? Tree map demo. No, this is map. Again, this is also from java.util import java.util.star. Tree map. No, we talk about hash map. No problem, you can go with any map here. Hash map, some map is equals to new hash map. Then how to add? It is not simple object here, pair of objects, key and value pairs. That's your choice how you want to add. Now let's suppose names and rule numbers kind of pairs I want to add here. Hash map dot, what is that method we need to use? Put a key and value pair. Oh, where is that put method gone? Dot put. Right? Just key and value pairs. That's requirement again. It's all your requirement dependent. Which one should be used at what area? 3, 4, and 1. Let's suppose 2. I don't know how I'm adding, and some values here. Values can be duplicated, but keys cannot be duplicated. If you try to duplicate the keys, it will allow you only one key and one value pair. Now I would like to print this map. System dot out dot println of hash map. Now save this. Okay. Use a tree map demo or something. We take it as map demo. This is easy. Then I'm going to change this program. Fine. Now let us compile the program and execute it. That Java. See there? It will not maintain any order of insertion. I am adding 1, 3, 4, 1, 2. But it is taking what? 1, 2, 3, 4. It's not sorting actually. It is not sorting. But if you add something in the middle, then you can get in a different order. And keys can be any objects because it is not maintaining any sorting order. So you can have different keys and different values also. 1, 2, 3, 4, 5 something it is coming later. It cannot sort it. This key cannot be right. This cannot be compared with any other thing. See this. So the data is added in the form of key and value pairs. Key and value, key and value, key and value, key and value. This entire key and value pairs all together is called as one map. Right? This entire key and value pairs is called as what? One map here, and you don't have any restrictions. Now, if I try to duplicate this, what I'm trying to duplicate here, I'm trying to duplicate a key. What is going to do for me? Is it going to allow? So first key is having AGA, and the second key is having TYT. Total, how many pairs are there here? 1, 2, 3, 4, 5, 6 pairs are there. Let's see what would be the outcome of this one. See how many are there now. Finally, there is no 6 pairs. There are only 5 pairs, and you see only one key. Duplicate key is eliminated. Old value is gone, and new value is there. If you see your collection, if you see your map, you see a new value, a key with new value. Old value is gone. But see, there are 2 duplicate values with 2 different keys. And same value has 2 different keys, I can say in simple. Right? So like this you have key and value pairs. Now if I change it to, actually it is storing in some order here. Actually, and you cannot predict the order of this one, how it is going to store and all. Yeah, see this? It's not sorting order actually. You have different order, 200, 3, 4, something it is internally. Actually it is internally uses hash codes to store this data. Right? Now if I change it to hash map to tree map, what it is going to do, this tree map? What this tree map is going to do for me? Right, so this tree map is going to sorting. Tree map is internally sorts the data. Now how it is going to sort the data? It sorts the data by using with the help of what? Keys. Now I can see your keys will be sorted, and you need to have what? Homogeneous. Keys must be homogeneous. See that your data keys are sorted here 2, 3, 4, 5, 100. But when I have a hash map, there is no ordering, but here sorting order. Now here if I have a key, let's suppose some key with ABC, is it going to sort me? Is it going to sort me this? Same properties of tree set, it will not do it because it cannot compare. If it wants to sort this, it should have what? The same type of data. Previously hash map is allowed to add this kind of pair, but tree map is not allowed because it arranges the keys in a set particular order. So when it tries to arrange the keys in a particular order, the data must be homogeneous. Keys must be homogeneous when you try to add the data to a tree map. Now it will not load. It's fine. Now it is arranged your data in a particular sorting order while by eliminating the duplicates. See, there are two duplicate keys and it is eliminated. Right? So it is completely eliminated my duplicate keys. Right? So it is arranging the data in a sorting order and by eliminating the duplicate keys here. Right, so this is what you have, complete architecture. So the same method I have used, put method. Now I have, if you want to see only keys, so what is there? If you want to see only keys, there is a method called as hashmap data key set. This method can be used to get only key values, only keys. All keys will be returned to you, whatever the keys you have in your map. See here, keys. If you want to see only values, you can go with a method called as values, which returns you only values of your map. See, you can see here, this is a different collection, this is a different collection. If you want to get key and value pairs, you can go for entry set. Entry set returns you the key and value pairs. See there, key and value pairs. The first one and last one almost look similar. Key and value pairs, only keys, only values, and here key and value pairs. It is not retrieving actually, just I am displaying. This is not retrieving. Retrieving means what? You need to get the data. This is not getting the data. Just they are going to show you what data is there. If you want to get it, you need to go with the iterators. You need to use the iterators and all to get the data. Right? So tree map like this. Now if you want to change this class, see here, hash table is also a what? Hash table is also a map. Can I change this class name to a hash table? Is it works for me? Hash table. Can I do this? Hash table. Hash table. Can I do this? Saying what error? TABEL. This is also error, I think. Let's see. Yep. Maybe T small. Yeah. Yeah. This is fine. Same. There is no difference. You can change this class. Hash table is also working, taking the key and value pairs. But there are slight differences you have between I can say hash map and hash table both are same. Hash map and hash table both are same. But one is old class, this very old class which is given in the initial release of Java. This is new class. So coming to performance, this is better. This has a better performance. This is bit lower in performance. Both are same. There is no difference. And when you create the object for hash map, it will have 16 locations. By default, it will have 16 locations. 16 storage locations will be there when you create a hash map. Right? So when you create a hash map, it will have 16 storage locations. Same as hash table also. But one special class which is used here in advanced Java, properties. Again, this is also a key and value pair, but the importance of this properties class is, right, the importance of this properties class is it allows key and values only string objects. It will not allow you to have any other objects. Right? If I change this class to a properties class, so what happens here? If I change this class to a properties class, what happens here is it will not allow you to do this because it must have, oh, it is allowing me. It's fine. It will allow you to have key and value pairs. Both must be of type what? Strings only. Yeah. It will allow you to have the key and value pairs. Both must be of type what? String keys and string values. But still it is allowing me, fine. And generally this class will not, it works with what? String keys and values. Strings. Pair of strings. Then only it works. Right. Okay, fine, it is working, no problem. Because I think that integers also internally converted to what? Strings. That is what it does. I'm expecting like that, right? Internally all these are converted to what? Strings. Let me take new student, whether it is, maybe this is also converted to a string, no problem. Fine. It is also converted to a string. So entire key and value pairs, whenever you have key and value pairs, it is going to add this key and value pairs in the form of what? Strings. But it has a different usage of this class, right? So whenever we see some kind of advanced Java program, there we try to see this properties. It has a different usage where the data will be stored in the form of strings. Right? So like this you have right, so what I'm going to do here is, okay, we'll take 30 and 40. Now how can I get the data? This key and value pair, how should I get this? You have a method called as map dot get, pass the key. When you pass the key, it returns you the data. But what I have there, I have a data in the form of what is the data? Integers, right? Get of one more key. What is the key I have? 3. Now I'm passing this, and I would like to see whether is it going to give me, because those two are integers I have added there. Now 5 is the key, and get method returns you the value of that 5. What it returns you? 30 will be returned in this place. 40 will be written in this place. If these two are treated as strings, then you will get 30, 40 because concatenation. If these two are written as integers, you will get what? 70. Did you get what I'm trying to do here? This is the key. By using the key, I'm trying to get the value. Returns you the value 30. Returns you the value 40 associated with this key. If it is returning you the data as integers, you will get 70. If it is returns the data as strings, you will get what? 30, 40. Let's see what it is going to give me. Error. Bad operand of type. You cannot use it because object plus object. Yes, you need to downcast it to your required object. It's not directly giving you. Fine. Fine. Then if you downcast it, you will get according to your data. You can get it. Fine. So this is what properties. Actually, you have different use with these properties. Whenever you have key and value pairs both in the form of strings, then you go for what? Properties. Right. So this is what collections framework here. This is what collections framework, working with group of objects instead of writing your own algorithms, taking the help of what? Existing algorithms. Saves you lots of time in development environments. Right? Instead of writing your own algorithm for searching, sorting, whatever you want to do, eliminating the duplicates and all, just make use of this framework. It is going to do all these operations for you.